Okay, good morning everyone. So in the previous
Good morning, sir.
Good
in
morning,
the
sir.
previous
Good morning, sir.
okay, thank you. Let's start the lecture now. In the previous lecture, what we have done is we have seen the types of matrices. We have seen operations on the matrices. After that, we have seen a row and column transformations. Transformations. This was the revision of what we have done in your 12th. Then we have defined rank. So the basic definition of rank was the highest order of highest non-zero minor of a matrix is nothing but the rank. So we saw that there were two methods to find out the rank. One was using echelon form, in which you roughly convert the matrix to a roughly upper triangular. Roughly
Sir left the meeting.
Okay.
okay, there was this network issue. So I'll start it once again. Okay, so rank of a matrix, order of the highest non-zero minor of a matrix. This was the basic definition that we have seen in the previous lecture. Then there were two methods to find out the rank. One is the echelon form, which is roughly upper triangular matrix. So once you convert a given matrix to roughly upper triangular, then number of non-zero rows will determine the rank of a matrix. So on this we have seen examples. Now today we will learn what is a normal form. Okay. We have seen in the previous lecture that in normal form we can use both row and column transformations simultaneously. Column transformations simultaneously, and you will make a roughly an identity matrix. A roughly identity matrix. identity matrix. What we have to do is we have to convert a given matrix to an identity matrix, and the order of identity matrix will determine the rank is the rank. Okay, so while solving the examples, you have to be very sure that whatever method I am telling you, the same method you have to follow, or else you won't get the final answer. So first of all, let's write down the definition of the normal form of A. Normal form by performing elementary transformations any non-zero matrix A, any non-zero matrix A can be reduced to one of the form. Can be reduced to one of the form. One of the form. The first one, simply it will turn out to be an identity matrix. This will happen only when the matrix A is a square matrix. Second, IR0. The third type which we can get is IR0, and the fourth one is IR000. So any of the four forms, we can convert any matrix to roughly an identity matrix, and I will get one of the form, and that form, whichever, if it is this one, the first one, then I'll say normal form of the matrix is this. If it turns out to be this one, second one, then I'll say the normal form of the matrix is this. So we will never be sure while starting our calculations that which of the form I will get. So I have to follow certain procedure while doing that, and whichever it leads to, that will be our normal form. So a quick remark over here. Rank of A is equal to R. What is the significance of R here? R stands for this IR. Whichever normal form you get, you can see that there is this IR, identity matrix of order R. So whatever order of identity matrix you get in that normal form, that will be your rank. So let me write it down. R is equal to order of identity matrix. And second and very important, both row and column transformations can be used. Both row and column transformations to be used. Fine. So I will give you example of each of this normal form, four of them. Say example number one, a matrix can turn out to be this one. I can get an identity matrix like this. If I am given a 3 by 3 matrix, I will do some row and column transformations, and finally if I'm getting this kind of matrix, then that a normal form will be IR, I3 in this case. The second case can be like this. So what you will get is 1, 1, 0, 0, 0, 0 here. So the matrix is of order 2 by 3, and I have reduced it to normal form, and finally what solution I am getting is this kind of matrix. Then the normal form will be I2, 0, the second one in our definition. For the third one, I can have a matrix like this, and the last row is 0. So I have 3 by 2 matrix given. I have done the operations and I am getting to this form. So what I have got here is I2, 0. Last and the important one. So 1, 1, 0, 0. Third column, third row, 0. So I can see that the identity matrix is up to this. So I2 is there, all the other entries are 0. So this is a normal form. So this is how you identify the normal form when you are solving a matrix. So we will solve some of the examples based on normal form now. Example. Reduce the following matrix. Following matrices to its normal form. To its normal form, and find the rank. And find rank. Now I'll tell you the procedure what you have to do. I'll do it here so that it is better understood. A11, A12, A13, A21, A22, A23, A31, A32, A33. So what do we have to do? First of all, make this entry 1, A11. Make A11 is equal to 1. The best choice is adding or subtracting two rows or interchanging. So what my first task is, A11 position जो है, there I should get 1. Okay. Then this is our first step. Step 1. Make A11 as 1. Step 2. Make below entries 0. Make below entries 0. So once I have A11 as 1, all the below entries need to be 0 in second step. But how we are going to make it 0? Using row transformation. Using a row transformation. Then the step number 3. Step 3 is make all the other row elements 0. Make right hand side entries 0. This I have to do using column transformation. Using column transformation. Remember this procedure. A11 entry 1, use row transformation, make all the below entries 0. Then you use the column transformation, make all the right hand side entries 0. Once I am done with this, what I will do is in step 4, I will make A22 entry 1. And again I will do the same thing. Use row transformation to make below entry 0. I will use column transformation to make right hand side entry 0. And this is the way how you have to go doing calculations diagonally. So I hope you are clear with the procedure. So I'll write on the matrix now. I'll rub this. So matrix number 1, A is equal to 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, 6, 3, 0, minus 7. Okay. So what is our first task? First task is to make this A11 entry 1. And that can be done simply by interchanging first and the second row. So operation is denoted by R12 since I'm interchanging rows. What I will have 1, minus 1, minus 2, minus 4, then 2, 3, minus 1, minus 1, 3, 1, 3, minus 2, 6, 3, 0, minus 7. I can also do one more operation, and that is R1 divided by 2. But what will this lead to? This will lead to 3 by 2, minus 1 by 2, minus 1 by 2. Rationals, just like I said in the previous lecture, are not good for our matrix operation. So I will not use this operation since I'm getting rationals over there. I want to always ignore the rational numbers. I have to do the operation in such a way that rationals don't come in the picture. Next. Now what I said, once you get A11 entry 1, use row operations to make all the below entries 0. So what we will have, R2 minus 2 times R1, R3 minus 3 times R1, R4 minus 6 times R1. So the matrix now will reduce to first row as it is 1, minus 1, minus 2, minus 4. The second row will turn out to be 0, 5, 3, 7, minus 1 plus 8, yes, 7, 0, 4, third one will be 9, the last one 10, and this will be 0, 9, 12, and 17. Someone do the calculations with me so that if there is any error, you can stop me over there. Now, what I said, once you get A11 entry 1, you have made all the below entries 0. Now I said that once you have all the below entries 0, step number 3, use column transformation to make all the entries on the right hand side of 1 to be 0. So we will have C2.
Sir, sir, in
Yes,
second row that 7 will be 5.
minus 1 plus 8. It will be 7.
8.
Yes,
Oh,
it's
sorry.
correct.
Yes,
Sir, it's
sorry, sir.
correct.
I
Sir,
have
it's
added.
correct. 7 is right.
Okay. Please. Rohan, please mute yourself so that I can go ahead. Huh. So C2 plus C1, C3 plus 2 times C1, C4 plus 4 times C1. So just like I said, now use column transformation to make the right hand side entry 0. So what do I get? 1, 0, 0, 0. First column as it is since there is no change. In the first row, all the entries will become 0 since I have done the calculations in that way. And what I can observe is 5, first column is 0 and I'm using the first column everywhere. So all the other entries will be same. 5, 3, 7, 4, 9, 10, 9, 12, 17. Now what I said, once we are done with this, below entry is 0, right hand side entry is 0. Now you bring 1, 1 at E22 position. And how can I do that? I can divide by 5, but 3 by 5, 7 by 5, that is not an option. So what I will do is, I will take R2 minus R3. So what will happen is 5 minus 4, A11 entry will become 1. So I'll go to the next page. So R2 minus R3, the matrix that I will get here is 1, 0, 0, 0. Third row will be as it is. 0, 4, 9, 10, 0, 9, 12, and 17. The second row will turn out to be 5 minus 4, 1, 3 minus 9, minus 6, and minus 3. 1 minus 6, minus 3. Okay. 1, 0, 1, minus 6, minus 3. Now, once I've got A2 to entry 1, follow the same procedure. Make the below entry 0. So R2 minus 4 times, R3 minus 4 times R2 and R4 minus 9 times R2. So 1, 0, 0, 0, 0, 1, minus 6, minus 3. Third, the first one will be 0, 0. This will be 9 plus 24. This is 33. This will be 22. And the last row will be 0, 0, 66. Then 17 minus 27, so 44. Okay. Now, once we are done with this, now go for right hand side entries C3 plus 6 times C2 and C4 plus 3 times C2. Once we do this operations, what will happen is I will make the right hand side entry 0. So 1, 0, 0, 0. Then you will have 0, 1. These two entries will become 0, 0, 0, 33, 22, 0, 0, 66, and 44. Please check the calculations. Now, I can see that C3 divided by 33 won't give me integers. You can check that. Even C4 divided by 20, sorry, it won't give me rationals. And C4 by 22 will also not give me rationals. So I can do these operations. So what I will get is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, and the last one will be 0, 0, 2, 2. Now R4 minus 2 times R3, or yes, fine. So what we will get? 1, 0, 0, 0, 0, 1, 0, 0. This will be 0, 0, 1, 1. And the last row will become completely 0. Then I will do the operation C4 minus C3. So with that, I'll get a matrix in this form. It will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. The last row will be 0, 0, 0, 0. So the normal form of A is I3. There is one column which is 0, one row which is 0, like this. This is the normal form. So the rank of A is equal to 3.
Sir?
Yes.
Sir, can you explain this example using echelon form, please, sir?
Echelon form, you can try it. I mean, we have done it in the previous lecture. Because it will be a lengthy one. I have to try normal examples today. You can try if it is, I mean, if you have some issues, you can simply send me on mail. So we will talk about it.
Okay, sir, no problem. Okay.
You try it once. If you don't get it, let me know.
Okay, sir.
Second example. A is equal to 1, 2, 3, 3, 1, 2. So I can see the A11 entry is already 1. So I don't have to do any calculation, directly make the below entry 0. So R2 minus 3 times R1. So what we get is 1, 2, 3. This will turn out to be 0. 1 minus 6, that will be minus 5. and 2 minus 9 minus 7. Then make the right hand side entry 0 using column transformation. C2 minus 2 times C1 and C3 minus 3 times C1. So the matrix that we get is 1 0 0 0 minus 5 minus 7. Look, there is an operation which says that, I mean, C. Okay, fine, we'll divide it. Minus 1 by 5 C2. So that will give me 1 0 0 0 1 minus 7. And C3 plus 7 times C2. That will give me the matrix of the form 1 0 0 0 1 0. So the normal form is I2 0. So the rank of A is, so rank of A is equal to 2. So I hope the procedure is clear now. So I will give you 5 minutes, and in that 5 minutes you can solve that example. So example number 3, A is equal to 1 1 0 0 0 0 1 1 1 2 1 2 2 4. Please do it.
So what's the second row, second term?
1 1.
Hi. अबे यार
Sir, rank is 2.
The rank is
2.
okay.
Sir, the rank is 1.
No, rank is not 1. That is for sure. Rank is not 1.
Sir, 2.
So 1.
Sir, 2. 2, sir.
Sir, 2.
Sir, 2.
Sir, 2. Yes, sir, 2. 2.
Yes, sir, 2.
2.
Okay.
Sir, is it 3?
Okay. So we have answered 2 and 3.
3, sir.
Okay. 3. Okay, let's try it then.
Sir, 2.
Now,
2.
okay. So 1, 1, 0, 2, 0, 1, 1, 2, 2 minus 1, 1, 1 minus 0, 1. Rank is 2. So the normal form for this, what you will get is
Sir, I2 0 0.
yes, I2 0 0 0.
Yes.
I2 0 0 0. Fine. One last example, then we'll see the next type. A is equal to 3, 2, 5, 7, 12. 1, 1, 2, 3, 5. 3, 3, 6, 9, 15. So the first operation R1 to 1, 1, 2, 3, 5. Then we will have 3, 2, 5, 7, 12, 3, 3, 6, 9, 15. So R2 minus 3 times R1, R3 minus 3 times R1. So we'll have 1, 1, 2, 3, 5 as it is. Change the second row.
Rank is 2.
2. Okay.
Yes, sir.
Yes, it is 2. So what we'll have? Minus 1, minus 1, minus 2, minus 3. The last row will become 0. Someone was asking me about echelon form. So look, this is the echelon form. You have 1, below entries are 0. The second next row, the first non-zero entry is on the right hand side. And then we will do the column operations, C2 minus C1, C3 minus 2 times C1, C4 minus 3 times C1, and C5 minus 5 times C1. So the matrix that we get is 1, 0, 0, 0, 0. Then 0, minus 1, minus 1, minus 2, minus 3, 0, 0, 0, 0, 0. The next C3 minus C2, C4 minus 2 times C2, C5 minus 3 times C2. So what we have is 1, 0, 0, 0, 0, 0, minus 1, 0, 0, 0. The last row is here. And then we have minus 1 into P2. So what we have is 1, 1, P. Fine. So the normal form for the matrix is I2, 0, 0, 0. The rank of A is 2. Okay. A small question for you now. I have a matrix A of order 3 by 4, say. Listen question carefully. How many distinct normal forms can we get? From this matrix of order 3 by 4.
So two
Yes, sir. 2.
forms.
Okay. Rohan said 2. Ananya said
3.
2. Any other?
3.
Sir, 3.
Mihika 3. Satish 3. Listen the question carefully. How many different normal forms can you get? Okay. For your convenience, I'll make a 3 by 4 matrix.
Sir, 20.
A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. So I will change this a bit now. Okay, if I make this different identity matrix, you can make in this. How many different orders of identity matrix you can make into this?
Sir, is it 20?
Who said 20? Pratik. Okay, let's try it out. Say for an example, just A11 is 1 and all the other entries are 0. That is a possibility. One possibility. Okay. A11 is equal to 1. All Aij is 0. Others. That is a normal form, of course. Then what I can get is this one, 2 by 2 matrix. Identity matrix I2. All the other entries 0. Then I will have a 3 by 3 matrix I3. 0. One column is 0 and you have identity matrix. And the last one, on 0 matrix. So how many possibilities are there? 3 possibilities are there. So 3 distinct normal forms you can get in this. Fine. So I hope normal form is clear. So I can give you 2 examples for homework. You can try it today and I will talk about it in the next lecture. In the next lecture, we will solve some linear equations.
लीव करना है क्या?
सर तो चले गए भाई।
लग तो ऐसे ही रहा है कि लीव करना है।
Wait, leave नहीं करना है. I have to download the attendance.
Oh, okay.
Sir, many of the
Please.
students left. About
So
10 to
many
12
students,
students.
like 13 students left.
Yes, sir, about 30.
ठीक है, I have the recording anyway, but just write down these 2 examples.
So we cannot see the screen.
Yeah, wait a minute.
सर
हम्म
सर इसको हमें सबमिट कहाँ करना है, मतलब या फिर सिर्फ सॉल्व
सबमिट
कर।
नहीं करना है, ये सिर्फ तुम्हारे प्रैक्टिस के लिए है. Since you don't have any books or anything else, so I'm giving you for practice.
ओके ओके सर, थैंक यू।
Yeah.
Sir, can we leave now? We have I have written down the questions.
Okay, fine. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Okay.